a straight wire of mass 200 gram and length 1.5 meter carries a current of 2 ampere. Here figure it is shown, AB is that wire. What's the mass? 200 grams. So you can write that mass is 200 grams, change it to kilogram. Then length of the wire is 1.5 meter. It is an SI system, so no need to change. Carries a current of 2 ampere. So current is 2 ampere. It is suspended in mid-air by a uniform horizontal magnetic. So it is suspended in mid-air by a magnetic field. By the magnetic, we know that wire is having weight, mass is 200 grams, so mg will be its weight. So due to mg, actually that wire would have fall downwards. So, but it is suspended stationary there with the help of a magnetic field here. So, it is suspended in mid-air by a uniform horizontal magnetic field vector B. What is the magnitude of the magnetic field? So, in order to suspend the wire in mid-air, what is the magnitude of the magnetic field needed? That is what we have to find out with the given values. We know when a current wire is kept around that, there is a magnetic field, and it experiences a force. Here already one magnetic field is there, that is marked with into mark. Into mark represents what? Magnetic field perpendicular to the plane and inwards. Into mark represent magnetic field perpendicular to this plane and inwards. That means it will be piercing through that screen like that, into that. Okay. So AB carries a current of 2 ampere as shown in figure. The weight mg of the wire acts vertically downwards. Therefore, according to Fleming's left-hand rule, the magnetic field B must be acting perpendicular into the plane of the paper. So, using right-hand rule, you are finding the direction of the magnetic field. Straight wire, you have to hold this wire with your right hand, with thumb showing the direction of current. Then, curl of the finger will represent the direction of magnetic field. Of unit, that it is suspended in mid-air by uniform horizontal magnetic field B. What is the magnitude of the magnetic field? That is what we have to find out. So, what is the magnetic force here? Magnetic force formula. Net is very weak. Not active. Magnetic force. Magnetic force is BIL sin theta. BIL sin theta, force acting on a conductor. BIL sin theta, that is balanced. That is balancing the weight of the wire, mg. So BIL sin theta equal to mg, and here theta equal to 90 degree. That means angle between magnetic field and current. Angle between magnetic field and current, that is 90 degree. So BIL sin theta is equal to mg. In that case only it can be suspended. So B is equal to mg by IL. So m is given, it is converted into kilogram, or into kilogram. G is 9.8 meter per second square. L equal to 1.5 meter, I equal to 2 ampere. Substituting, we get 0.65 Tesla. That is the magnitude of the magnetic field. Okay, next question. A short conductor of length 5 centimeter is placed parallel to a long conductor. So here we are discussing the case of two straight parallel conductors carrying current. That case, what is the force experienced? Short conductor of length 50 centimeter is placed parallel to a long conductor of length 1.5 meter. Near its center, near to the center, it is kept. So two conductors are there. One is having length 5 centimeter, other is having length 1.5 meter, very long compared to this. The conductors carry currents. First one carry current 4 ampere, the other, the long one carry 3 ampere respectively. So two conductors are there and they carry current 4 ampere and 3 ampere respectively in the same direction. So note that point, in the same direction they carry current. When current flow in the same direction. Okay. 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 So here two conductors carry current in the same direction. Same direction, what will happen? Is it attractive or repulsive? It will be attractive force, same direction. If opposite direction, the force between them will be repulsive. That derivation we have studied earlier. So all of you study the derivations. Don't think that always the question will be MCQ. Board exam may be descriptive. We don't know about that. So usually that is the practice. 1 mark, 2 mark, 3 mark, 5 mark, like that. So you have to prepare for that. All the derivations write and study. Formulas by heart, like that. So whenever you get time, don't waste the time. Utilize it properly. As the two conductors have different lengths, the longer conductor may be considered to be infinite length. Therefore, magnetic field produced by it at a distance of 3 centimeter is. So you can use two formulas. Either first find magnetic field and then find force, F equal to BIL formula. Or you can use the formula that you have studied, mu0 by 4 pi 2 I1 I2 by R, force per unit length into length you can do, length of the short conductor. Two methods are there. One is first finding first conductor produce a magnetic field around it. That magnetic field you can find B equal to mu0 I2 by 2 pi R. Then you find magnetic field is here BIL sin theta. Theta will be 90 here. When you draw the figure, you will see that theta will be 90. So BIL formula you can use. There is another method also. Which is the other method? Directly you can use the formula mu0 by 4 pi 2 I1 I2 by R into length of the short conductor. That method also you can use. So here this method is used. First find magnetic field, then find BIL. Sin theta, theta becomes 90. So first find B, magnetic field. Magnetic field produced by it at a distance of 3 centimeter is given by first conductor mu0 I by 2 pi R. So I2 is the current flowing through that conductor. So magnetic field produced by it will be mu0 I2 by 2 pi R. That formula we got the magnetic field. Then force is determined with.
Again, admit ചെയ്യാൻ
Najmala also. Not see, now 18 only joined. See, everyone is late. So BIL formula is used, and according to Newton's third law, the longer conductor will also experience the force of reaction equal to the same. So force on long conductor equal to force on short conductor. So that force will be same. As the currents are in the same direction, the force is attractive. Okay. That is one more. And we will be doing another problem of similar type using the other problem. Next question. What is the magnitude of force on a wire of length 0.04 meter? So when you read, you can write all the quantities. Length equal to 0.04 meter. Placed inside a solenoid. So that wire of length is placed inside the solenoid near its center, making an angle. So angle made by that is given 30 degrees with its axis. Wire carries a current. So what is kept inside the solenoid? Current carrying wire. What's the current? 12 ampere. And what's the length of that conductor cap, current carrying wire cap? 0.04 meter. But I is given, L is given, theta is given. Then the wire carries a current of 12 ampere, and the magnetic field due to the solenoid is magnetic. That is also given. Magnitude of the magnetic field inside the solenoid also is given 0.25 Tesla. So directly you can use this formula. BIL sin theta. B is given, I is given, L is given, theta is given. So you get the answer in Newton. This force, magnitude of the force. So unit will be in Newton. Okay. This is an important problem. A rectangular loop of side 25 centimeter and 10 centimeter carrying a current of 15 ampere is placed with its longer side parallel to long straight conductor 20 centimeter apart carrying a current of 25 ampere. What is the net force acting on the loop? It's an important question. It is all questions that we discussed are board questions. So here you can see a long conductor. It carries a current of 25 ampere. Here you see you have to draw the figure. I think as shown in figure it is not mentioned like that. You have to draw the figure. A rectangular loop of side 25 centimeter and 10 centimeter. So this is the longer side of the rectangular loop, and this is the shorter side of the breadth of the rectangular loop, carrying a current of 50 ampere. So this first you have to draw the rectangular loop, and then current also you can mark 15 ampere close to AB part of the rectangular loop. Okay, then this is this longer side parallel to a long straight conductor. Its longer side is parallel. So when you draw it, be careful. This is the longer side. Longer side is parallel to a very long conductor, the XY. Parallel to a long straight conductor, 20 centimeter apart. Sorry, this is. Yeah, I am not seeing here in the list. Now she is. So longer side is kept parallel to the this long straight conductor. Okay, and this is not 22, 2.0, 2 centimeter apart. So the separation between them is AB and XY. Separation between AB and XY is only 2 centimeter. Okay, apart, carrying a current of 25 ampere. This long conductor is carrying a current of 25 ampere. So let us take this as I1 and this as I2. And here what is asked, what is the net force acting on the loop? So we know when a rectangular loop carrying current is kept here, each part of the conductor AB will experience force, BC will experience force, CD will experience force because, and DA also will experience force because it is in the magnetic field produced by this conductor XY. So XY 25 ampere current is flowing through XY. So around that there is a magnetic field. So this rectangular coil is kept in the magnetic field produced by this straight conductor XY carrying a current. So each part of the conductor will experience a force, and we have to find out the net force acting on the conductor. So each conductor you have to find, and uh, these conductors B, C and CD, they are at equal distance from the conductor, and the current flowing are in opposite direction. One is upwards, one is downwards, and they are equidistant from the conductor. Equidistant from the conductor. So these conductors B, C and CD, they will experience force, but they will cancel because that will be equal and opposite. Equal and opposite, equidistant from it. So that force acting on it will be a L sin theta. If you find that will be cancelled. Force acting on conductor BC will be equal and opposite to force acting on conductor AD. So in effect, net force due to the current flowing through this conductor will be cancelled. So only to discuss about this conductor only AB and CD. We have to do because they are not equal distance. They are at different distances from the conductor XY. So here you can see the AB and XY. What is the separation? 2 centimeter. But what is BC? Breadth of the coil is given. That is 10 centimeter. So CD conductor is at a distance of 12 centimeter. 10 plus 2. 10 plus 2 is there. 12 centimeter. So CD is at a distance 12 centimeter from XY. AB is at a distance 2 centimeter only. So this distance is very small compared to this one. And also you must know AB and XY current are flowing in same direction. Arrow mark, you see the arrow mark? AB and XY current is flowing in the same direction. But CD and XY current are flowing in opposite direction. And what is the formula that we have to use? V0 by 4 pi 2 I1 I2 by R. That is the formula. V0 by 4 pi 2 I1 I2 by R. So which force will be more? R is coming in the denominator. A force acting per unit length equal to V0 by 4 pi 2 I1 I2 by R. R is in the denominator. So when R increases, what happened to force? I'll ask question. F equal to V0 by 4 pi 2 I1 I2 by R. When R increases, see for the conductor CD, R is increasing. When R increases, what happened to force? What happened to force? Ganesham, what happened to force? Ganesham, are you hearing? Very simple question I asked. Even then you are not answering. F equal to V0 by 4 pi 2 I1 I2 by R. When R increases, what happens to force? F and R are inversely proportional. When R increases, what happens to force? Very simple question. Tell the answer. When R increases, what happens to force?
Force decreases.
Force decreases. That is the question. So here, CD conductor will experience less force than AB conductor. CD conductor experience a repulsive force. AB conductor experience an attractive force because they are in the same direction. So net force, will it be attractive or repulsive? Will it be attractive or repulsive? Net force. AB conductor experience an attractive force, more attractive force because that is closer to it. So force, attractive force is more than the repulsive force. So net force will be what? Attractive. Net force will be attractive. Okay. So now we can do the calculation. What is the attractive force? What is the repulsive force? What is the net force? That we can find out. You see, force on AB, V0 by 4 pi 2 I1 I2 by R into length of the conductor. If one conductor is shorter and the other conductor is longer, what we do here when we find force, we have to multiply it with length of the short conductor. Length of the short conductor is 25 into 10 raised to minus 2 meter. So substitute all the values. Mu 0, what's the value? 4 pi into 10 raised to minus 7. So divided by 4 pi, 4 pi, 4 pi cancel. But we get 10 raised to minus 7 only there. 4 pi get cancelled. And next 2 into current I1 15 ampere, current I2 25 ampere by distance between them 2, that we have changed into meter. 2 into 10 raised to minus 2 meter. And into length of the short conductor. So we got the answer. We know they are attractive force. They exert attractive force. So we got that answer. Next, we can find out the force on the conductor CD, which is at a distance 12 centimeter from it. So only change is in the R2. The R2. Length is same. So instead of 2, you have to write 12. So you see what is happening. Here it is 9.375 into 10 raised to 4. Here you see when you calculate the value, very much reduced. 1.5625 into 10 raised to minus 4 repulsive force. So attractive force is more than the repulsive force. So net force on the loop is equal to F1 minus F2. So subtract that and we get the answer. 7.8 into 10 raised to minus 4 Newton bracket. You have to write net force is attractive force. So you can see thus the force on the loop will act towards the long conductor attractive. They will attract each other. If the current is in the closer side is in the same direction. If the current in the closer side is in the same direction, there will be an attractive force. So that is an important question. Another question of the, yes, similar equation we are using. Same equation. So calculate the force per unit length. You have to listen that part. Force per unit length is asked. Whether it is force is asked or force per unit length is asked. Be careful. Force per unit length on a long straight wire carrying a current of 4 ampere due to a parallel wire carrying a current of 6 ampere. Distance between them is between the wire is 3 cm, which is a direct question. It's also a broad question. Sometimes some direct question also asked. Okay. So I1 is given, current flowing through one conductor 4 ampere, current flowing through the other conductor 6 ampere, and separation between them 3 centimeter, change into meter. Don't forget 3 centimeter, change into meter. Force per unit length formula is 0 by 4 pi 2 I1 I2 by R, and 2 get cancelled. So you get mu 0 by 2 pi into I1 I2 by R, or mu 0 I1 I2 by 2 pi R. That is the formula. And substitute the value. Mu 0 value is 4 pi into 10 raised to minus 7 into I1 4. Substitute I2 6 by 2 pi into 3 into 10 raised to minus 2. Separation. 3 separation. So you can find out the answer by doing the calculation, get the answer, and it will be 1.6 into 10 raised to minus 4. You have to check these answers by doing calculation. Then only you will get speed. So how to study these problems? I am giving some problems, extra problems also. You have to do from some question banks. Previous board questions will be there. Do that questions, derivation questions, etc. If you are not having any that question bank, you will get it fast because you are having this on a vacation time by online. You can get it. Different books are available in market. Then you anyway you have to get one book. Then you can do extra questions, extra problems also you can do. So try to get one book by online and study. So next question we can see. A rectangular coil of area.
Sir,
Yes.
Abhinav University.
Abhinav is. So next question. A rectangular coil of area 5 into 10 raised to minus 4 meters square and 60 turns. When you read, you can write the area equal to 5 into 10 raised to 4 meters to check whether the unit is in a SI system. Then 60 turns, capital N number of turns, 60, pivoted about one of its vertical side, pivoted about one of its vertical side. The coil is in radial horizontal field. Very important this factor. Radial. What is meant by radial? Radial means the field lines are in the plane of the coil. For any orientation, the field lines are in the plane of the coil. Very important. One mark question. As a one mark question also, it asks what's the radial field. The radial field means always plane of the coil will be parallel to the magnetic field. Then it experiences maximum torque. Understand? That is the advantage of radial field. Plane of the coil is parallel to the magnetic field. Okay. Theta will be 0. And NIBA cos theta 0. Maximum torque will be NIBA. And here what is asked, what is the torsional constant? Torsional constant we have to find out. Torsional constant means K. Torsional constant of the hair spring connected to the coil. If a current of 0.20 milliampere, you have to change it to ampere, milliampere, produces an angular deflection of 18 degrees. So all the values you can write. Magnetic field is and 90 Gauss it is given, so that you have to convert into Tesla. 1 Gauss, that you should know. 90 Gauss. 1 Gauss is 10 raised to minus.
ടീച്ചർ അക്ഷയനെ കയറ്റാൻ പറഞ്ഞു.
Okay. Here torsional constant of the spring K equal to NI. Which formula is this? Do you remember? Moving coil galvanometer. NIBA, that is the magnetic torque, and this is the restoring torque, or restoring torque per K is the restoring torque per unit twist, or another name torsional constant. So K alpha is the deflection. K alpha equal to NIBA in equilibrium position. All these are theory, and this is theory part. So formula study very well, then only you can do these problems. So N value substitute, N is given 60, I is given 0.2 milliampere, so change it into ampere, and B is given 90 Gauss. Gauss is the CGS unit of magnetic field induction, so convert into SI unit, multiplying by 10 raised to minus 4 into area. Area is also given 5 into 10 raised to minus 4 by 18 degree. So that is substituted, and we get the answer. Newton meter degree raised to minus 1. The next question. A moving coil galvanometer has the following particulars. Number of turns is given, N equal to 24. Area of the coil A equal to 20 into 10 raised to minus 3 meters square. Magnetic field strength B equal to, everything is given. Resistance of the coil R equal to 14 ohm. First question, indicate a simple way to increase the current sensitivity of the meter by 25%. This type of question usually asked. Find current sensitivity, or how to increase the current sensitivity by 25%, like that, or what will happen to the voltage sensitivity, like that questions usually asked. So these are also important questions. Indicate a simple way to increase the current sensitivity of the meter by 25%. It is not easy to change A or B. A or B means area or magnetic field induction. So what we will turn number of turns. We can change, increase the number of turns. For what? To increase the current sensitivity. Currents, yes. Question, remaining part. Second part. If in doing so, that means we are increasing the current sensitivity. The resistance of the coil increases to 21 ohm because by increasing the number of turns increasing, what happened? Length is increasing, length of the wire is increasing, and resistance is increasing. So, by increasing the current sensitivity, if the resistance of the coil increases to 21 ohm, suppose we are increasing the number of turns and by 25%. And by doing so, if the resistance also is increasing to 21 ohm, earlier it was 14 only, now it is 21. Then is the voltage sensitivity of the modified meter greater or less than the original meter? That you have to find out. So voltage sensitivity also you have to find out and check whether it is earlier one or the modified one which is greater or lesser. That you have to find out. So current sensitivity formula we have studied alpha deflection per unit current. That formula NIBA equal to K alpha, that formula is used here, and deflection per unit current alpha by I equal to NBA by K. So how can you increase the current sensitivity? That is also an important question. How can you increase the current sensitivity? By increasing N, increasing B, increasing A, decreasing K. That is the method. Here we are increasing N. It is easier to change N than K, A or B. So, the current sensitivity can be increased by increasing N. To increase it by 25%, N should be increased from 24 to 30. So, already it is having 24 turns. And now we have to increase the current sensitivity by, they are directly proportional. Current sensitivity and N are directly proportional. So increasing the current sensitivity by 25%, you have to increase the number of turns by 25%. So the number of 25%, 24 is a number of turns it is having. How will you increase 25%? 24 into 25 by 100, you find out. So you will get the answer 6. So 6 more turns are needed to increase the number of turns 25%. 6 more turns. Already it is having 24 turns. So plus 6 it will be 30 turns. So 30 turns of the wire are needed to increase the current sensitivity by 25%. So okay, now the number of turns is 30. Now we can find out the voltage sensitivity. Voltage sensitivity is deflection per unit voltage. Deflection per unit voltage. So deflection per current is current sensitivity by R. Alpha by I into R. V is equal to I into R. The by Ohm's law. V equal to E into R. Alpha by I is already we know this is the alpha by I, NBA by K, that is here NBA by K, then R is there in the denominator, that is written NBA by KR, that is the voltage sensitivity. So here as K, A, B are same in the two cases, we need to compare only N by R. N by R only, all the other values are same. We have changed only N and R, there by R. So we need to compare only N by R ratio. For original meter, what is N by R? Original meter 24 by 40 equal to 1.7. And for the converted one, what is the number of turns? 30. And what is the resistance? 21. It is written. So, modified meter N by R equal to 30 by 21. Modified meter. So, it is 1.4. Thus, the modified meter has less voltage sensitivity than the original meter. Original meter, what is the sensitivity we got? By R ratio. One point seven. Modified meter. 5 minutes more. For modified meter, 1.4. Thus, the modified meter has less voltage sensitivity than the yes. Current sensitivity is equal to alpha by A equal to NBA by K, and voltage sensitivity is equal to NBA by KR. So, and here we have determined voltage sensitivity NBA by KR. So, N by R ratio for original meter 1.7 and the converted meter 1.4 only. Isn't it? Yes, 1.4. So, it is reduced. So, it is reduced to 1.4. Thus, the modified meter has less voltage sensitivity than the original meter. By increasing the number, this is also one important point. By increasing the number of turns, it has gained in current sensitivity but lost in voltage sensitivity. Very important point. By increasing the current sensitivity, the voltage sensitivity reduced here. So it is not necessary that when current sensitivity increases, the voltage sensitivity also increases. Don't think like that. Here, by this problem, we have seen the current sensitivity is increased, but voltage sensitivity is reduced here.